It's that time. We finally made it to a sequence. I know you're excited. And a sequence is just a list of numbers that follow a pattern. Okay? And in this example, they've given us the first term in a sequence. They've given us the R, which we'll talk about what it means, and we want to know the ninth term. And the way we find a term is they're related to the terms that come before them. There's a recursive formula, which we can use to find the next three terms. Okay, so this is a common ratio. And a common ratio is something that you multiply by over and over again. So for our purposes, if we want to go from 4 to the next term, we have to multiply by -4. It gets us -16. And then we multiply by -4 again. We get 64. And then we multiply by -4 again. We get -256. And so on. That sequence would just keep on going. So this would be, this is the first term, second term, third term, fourth term. And the way we label those would be A sub 1, A sub 2, A sub 3, A sub 4, where A just means term, and then the number tells you which term you're talking about. Okay, and when we wrote our equations, or not our equations, when we wrote our explicit formula, we would look for the term that came before the 4, which we called the 0th term, if it existed. And to do that, we have to do the opposite of multiplying by -4, which is to divide by -4. And we get 4 divided by 4 is -1. So let's write a formula. Any term is equal to, so let's say we started with -1. We multiply by the common ratio, -4. I'm actually going to put it in parentheses. And how many times do we have to multiply by -4 to get to the first term? Just once. And it's the first term, that's n. How many times do we have to multiply by -4 to get to the second term? 1, 2. So the exponent here is n. It's whatever term we're looking for. That's how many common ratios we have to do to get there from -1. And so for this one, I haven't said it yet, don't know why, but this is geometric because it has a common ratio. Constant multiplication, that's geometric. Goes with an exponential function, which we talked about some. And then the other option is arithmetic, which goes with a linear function. But here's our explicit formula. If we want the ninth term, that's -1 times -4 to the ninth power. -4. When you do this, make sure you put this in parentheses. In this case, it wouldn't make a difference, but it often does and messes people up. So, wow. And then we gotta multiply by -1, which just changes the sign. 262,144. Ninth term, 262,144. Big number. Okay, because geometric growth or exponential growth is very quick. Big constant multiplication.